Good afternoon, everybody, and welcome at this presentation where we are going to talk about boring. Boring is, I sometimes compare boring kind of in the machining area a little bit like what people call the forgotten vegetables. It's a machining operation. Not a lot of people talk about. Everybody talks about turning and milling and drilling and all that type of stuff. But boring as a machining operation, in my eyes at least, is still a cornerstone in modern machining, especially there where quality, where precision of finished holes is important. And you know, in the present world where we all like to talk about sustainability and cost efficiency and so on, I think even more than before we have to give boring its rightful place on the scene, because you know, if you are making a hole, a bore, and you fail on reaching the needed quality, the tolerances, the surface roughness, the correct position of the hole, and so on, it could mean that you have to scrap the workpiece. It could mean that you have to rework the workpiece. And in the light of cost efficiency and sustainable operations, could be a rather big problem. Welcome. My name is Patrick de Vos. I'm your host this afternoon, where we are going to discuss boring. But as always, I'm not alone here. I have Alesia and Margarita here who do the technical work behind the scenes to make all of this possible. And today also we have a special guest, Fabio, who is the real expert when it comes to boring applications.
Hello, everyone. I'm Fabio Predieri from Seco Italy, and today I'm going to show you an application of a large boring bridge.
Nice, thank you very much. So Fabio I'm going to kind of first give a general picture of boring, very short. But Fabio is going to dive in a real application then with a kind of a specific boring tool, which we call boring bridges. And boring itself is a very specific operation, but within boring, working with boring bridges, that is really where all the skills, all the expertise comes together. Today, it's a short presentation. What we use here is an abstract from a boring seminar, a boring course, which takes roughly a day, where we dive into all kinds of details around this application. Today we are going to talk just about some highlights in it. And for your information, while we are talking here, and especially when Fabio presents his specific case, I'm rather sure that some of you will have concrete questions about your applications. I have to do this, I have to do that, I'm doing this and it's not working. During the presentation, there is an option for you to book a 30 minutes free meeting with one of our global boring specialists to talk about really concrete about your concrete applications. To have some advice, to have some guidelines, how to do things, how to tackle things. You see on the screen now a QR code. If you scan it, you go directly to where you can book the meeting. And as that, this thing can become really concrete for you. Now, boring as an application, as I said, it's an old. It's one of the classic operations in machining, but we kind of tend to forget it. But if you look today to the machining world, what we see clearly is that quality demands of finished workpieces are increasing. It's a trend going on since ever and still not stopped. We are demanding from a machining operation more and more that a high quality is the result of the operation. And if you fail reaching the quality, if you have to reject a workpiece because you missed it, it's an expensive exercise. And especially you have to think in that respect that very often hole-making operations, as boring hole finishing operations, they kind of come at the end of things. where before already the workpiece has went through quite a lot of other operations. So if you have to reject a workpiece, it's an expensive exercise. Perhaps you say, I don't have to throw it away, I can rework it. But people, rework is also not free of charge, huh? It takes time, it takes energy, it takes capacity of your machines. So be careful with rework. I sometimes have a feeling people say, rework, well, okay, we put it back on the machine and we correct and nothing happened. It's not really like that. And in many cases, boring, being kind of at the end of the chain, is kind of, when it comes to whole operations, quality and stuff, it's your last chance to get things right. It's truly a finishing operation. So it's your last chance. And if something is your last chance, you better pay good attention to it. That's kind of the message I want to give you here. Because boring, when we talk about a whole with a certain function in which a bearing is going to be placed, or that guides something. The functional correctness of the whole, the surface roughness, the positioning of the whole, it's all depending on how good, how well you manage to perform the boring operation correct. Now, boring, I a couple of times I said boring is a finishing operation. That's only partly true, because boring is kind of also a roughing operation, because boring is defined as a machining process, internal machining, so hole making, to enlarge, refine, and finish an existing hole. So especially the first part, enlarge an existing hole, that one could say that's a roughing operation. And it's very classic that boring comes in two steps. Kind of first a rough operation to enlarge the diameter to where we come close to what it needs to be finished. And then we have a second part in the operation, which is finish boring. The final target of an operation is to achieve a hole with the correct shape, the correct geometry, the correct dimensions, the correct surface roughness, and also the correct position. And I'm going to come back on that position thing, because it's very important, and it's kind of a unique thing for boring. If you compare it with other hole making operations, and that's what people always like to do, if to take boring, but how is boring compared to drilling, and what is reaming in the picture, and so on. And I'm going to do that together with you very briefly, putting all those operations next to each other and see what, where, and how. Now, boring is an operation, it's a finishing operation. It has the capacity to correct errors done in prior processes. If the hole is drilled and the position is not very correct, with boring you have the possibility to correct that. So boring corrects errors from previous operations, and at the same time it makes sure that the finished hole, the bore, is conform the quality demands which are put on the feature. Now, two considerations I want to give you with this. One is that the quality after finish boring, the quality of the hole is also depending on how good the existing hole before we started the boring operations is. Because boring is quite an interesting operation, but you can't do magic. I mean, if the existing hole is completely wrong, even boring cannot fully correct that. So don't make a mistake by thinking, I don't care so much about making the first initial hole, because afterwards I do boring and everything ends up fine. Be careful with that. Another thing with boring is that a boring tool, by definition, is an adjustable tool. The operator or the setter or whoever prepares the machine, does the setup, has to set the tool. And the correctness, the precision with which the setting is done is of course a key element for the operation. If your boring tool is set at the wrong diameter, yeah, the diameter after boring will be wrong. Not because the operation went wrong, but because your tool was set in a wrong manner. And that means that if I take those two considerations together, that the expertise of the people doing the operation, more than in other operations perhaps, is of utmost importance. Boring is an operation that you can't leave in the hands of juniors, if you allow me to put it like that. A boring operation supposes an experienced engineer, operator to handle the tool in the correct way. As I already said, boring is used in existing holes, enlarge existing holes, correct the quality or bring the quality of a finished hole to the level I want to bring it. And boring is in that respect a member in the family of hole making operations, where we have other operations like drilling, pre-drilling, step drilling, drilling with insert drills, reaming, all that type of operations we call a family the hole-making operations. The tools for it are hole-making tools, and one of those members is boring. Now, boring, comparing it with other operations is a bit a difficult thing, because there are so much overlapping things. What I try to do here is give you a picture, an image of all the family members here. You have the very traditional, the very classic drilling a hole with a twist drill in high-speed steel, a twist drill in solid carbide, whatever. It's very typical. I would say it's a roughing operation. There is no hole, and then you do a drilling operations, and there is a hole afterwards. Demanding quality things of that hole, to some extent you can do, but kind of by definition, if you compare drilling with twist drills with the very traditional finishing operations like reaming and boring, we should classify drilling as a roughing operation. Now, I know that some people would say, yeah, but wait a second, if we talk about solid carbide drills, we can reach very high precisions, which is a very absolutely correct statement to make. But I try to give you the general picture here. I would say drilling with twist drills, smaller holes, roughing operations in smaller holes where boring is impossible to use because the tools are not small enough. These tools in solid carbide to some extent can be used as finishing tools also. Drilling with insert drills. The picture here is very clear. If you have the bigger diameters, and if in a big diameter you would use a twist drill, it's going to take forever, because you first drill a small diameter and then you up drill to a bigger diameter and again a bigger diameter and yet a bigger diameter. An insert drill gives you the possibility with bigger diameters to make a hole in one go. So it's for bigger diameters a more productive manner of making a hole. On the other hand, this is truly a roughing operation, because the quality of the drilled hole, due to the machining process itself here. I hope one day to have the opportunity here to talk to you about the process of drilling with insert drills, because it's a very specific process. But the quality of the hole, I would say you cannot have demands. You have a hole. And tolerances and roughness and that type of stuff is it's part of the game that it's I should not say not so good, but it's not the higher quality. Then on lathes we use boring bars, internal turning, which is also a member here of the family of boring operations or hole making operations. I guess most of you are familiar with this. It's a turning operation, internal turning. It's a simple tooling, easy to use. It's the accuracy of the machine, basically, that defines the quality of the internal turned hole. There are some restrictions here. I would say it's mainly with deeper holes where there will be vibration issues, and you will have to take care of them. Helical interpolation milling, circular milling, helicoidal milling, one could say is kind of a hole-making operation. It's very typical, a very flexible operation, because the hole doesn't even need to be cylindrical when you select this as an operation. On the other hand, it's a slow operation. Drilling a hole is rather fast. Boring a hole is fast. Milling a hole kind of takes a long time. And by definition, the surface will not be cylindrical but scalloped due to the milling process itself. Reaming. The big competitor of boring, one could say, because that's an eternal discussion between specialists. What is best now, reaming or boring? Reaming is an operation that goes fast. That gives you high quality, but there are some limits to reaming. Reaming is an operation where the existing hole in which you are going to do reaming needs to be very close already to the diameter you want it to be. There does not exist something like rough reaming. Reaming is improving some geometrical elements of a hole. The tolerances, of course, the surface roughness, of course, but reaming as an operation, if you talk, for instance, about the correctness of the position of the hole, reaming is not really going to correct that. From a tooling perspective, reamers are relatively not flexible. You have one reamer, you have one diameter, and kind of that's it. Boring then. There is boring we use as an operation to enlarge holes. We refer then to rough boring. And there is a boring operation where we are going to make sure the hole has the correct shape, tolerances, dimensional tolerances, position, surface roughness, and so on. And then we talk about, we call the operation finish boring. I would say for me now, because as I said, if you end up in discussions with machining people, some see things their way and others see it slightly different. For me, boring is an operation where you have a rather high flexibility. With kind of a limited amount of tools, you can do quite a lot of different types of operations. Boring as a finishing operation is working on all quality things in a hole. The dimensions, the surface roughness, the position, the shape, the geometry. From a productivity perspective, one could say, typical for the operation itself, it gives you a slower machining than drilling or reaming. That's a bit part of the game here. And as I already said, boring as an operation, there is, for me, in my eyes, one big demand. And the demand is the operator, the engineer, working with the tool. You need a senior. You need somebody who knows what he's doing. Not only from the operation perspective, doing the actual boring, but also about handling the tool. Because a boring tool, by definition, needs to be set, needs to be prepared for the operation you have in hand or at hand. I give you here an overview. It's a matrix. I think every single box in this matrix can lead to a discussion. What I try to do here for you is vertical. I rank the different types of hole making operations. drilling with twist drills, insert drills, turning boring bars, milling, reaming, and boring. And then advantages, disadvantages, where do we use it in general? How accurate, dimensional-wise, can you get with that technique? How is it with surface finish, and how is it with flexibility? Flexibility, with that I mean, to which extent can you use with a limited number of tools a wider range of applications. You see here that for the accuracy I give numbers, for surface finish not, because that's a bit of a problem, because the surface finish you can reach with each of these operations is not only depending on the tool, but is also depending on other elements in the process. The accuracy of the machine, the stability of the machine, the stability of the workpiece, and so on. So here, to avoid that there are discussions afterwards, I limit to calling a surface finish low, moderate, or good. It gives an idea. The big discussion, however, always I have been in hundreds of discussions, is what is best, reaming or boring? And that's why in more detail I put the two operations here. I'm not going to read the whole table together with you. You can read yourself. And by the way, a copy of this presentation, for those who are interested, just let us know and we send you a copy. Then you can evaluate, for instance, this table here. It gives you, for a lot of different points, how to position reaming and boring compared to each other. There are, however, two things which are not in this table, and they are even so very important. One I would call your personal preference. Because a machinist, based on his experience, based on the expertise he has, based on the knowledge he possesses, kind of in a natural way tend to one of the two. Personal preference, and it's important, and I think it's important, and we have to respect it, because if somebody feels familiar with a certain tool, he will be capable of using it in a much better way. Personal preference. The other thing is, in the company, what's the company's opinion on this? With other words, in what did the company invest before? What did management decide? For finishing operations, does the company prefer boring as first choice? Or in other companies, people will say, no, we, based on company objectives, we go for reaming as an operation. And those two, next to technical stuff, we need to take into consideration also. Boring is a hole making operation, is a hole finishing operation. It's part of a family with a lot of members. Using boring as an operation, I said it 2 or 3 times now, but I think it's so important. If you think this is the operation you want to do, make sure that the people using the tools, the people setting the tools, the people selecting the tools, they know what they are talking about. Because in that respect, boring, I'm not calling boring difficult, but I call it an operation that demands seniority, that demands experience, that demands expertise from the ones using the operation. Fundamentals of boring, where can we use boring? How do we use boring? If we have that discussion, and I'm going to be a bit fast here, the first important thing, and people sometimes tend to forget it, is what type of hole are you going to use the boring tool in? Is it a through hole, a blind hole? Are they cross holes? Is it interrupted cuts, stepped holes, big diameter holes, deep holes? It's an important consideration not to overlook. And boring, as I said, there are two big parts in it. You have rough boring and you have finish boring. Rough boring is about removing material in a fast way without having too big demands on quality. Rough boring heads are developed for that. What we very often see with rough boring heads is that it's twin cutters, 2 cutting edges. In a number of cases, even 3 or 4 cutting edges on a boring head. There are different ways of positioning those inserts. Perhaps you heard about people talking about symmetrical setting or staggered setting, which it's all about setting a rough boring head in such a way that it fulfills its target, being fast removing material, thus in the best possible way. Next, we have finish boring. Finish boring is where we say it's not about removing a lot of material. Here it's about creating a surface in a hole that is in line with expectations from quality. Dimensions, surface roughnesses, shape and form, and position. That's the target here. And here again, I give you a table where I kind of, in a vertical way, rank all the different types of boring bars and boring heads there exist. Again, here, if you want more detailed information on this, take the opportunity with the Teams meeting you can register for to dive in depth here about what would be best for you. And again, here I give you the application range, some key features of a certain type of tool, advantages and disadvantages. But also here you will see there's quite a lot of gray area. And in the end, if you have to make your selection, it's about the whole you want to produce, the workpiece material, how many workpieces do you want to produce, and so on and so forth. And I give you this just to let you understand what I mean with seniority. If you use a boring tool, you prepare the machine, you do setup, and at one moment in time, somebody, the setter or the operator, whoever set up the machine, decides, now I'm ready, let's go. Start cutting. Now, for boring, the checklist you have to go through, by means of speaking, to ask yourself the question, are we ready? Can we push the start button? Well, here you have the checklist. All of these points, all of these elements have to be checked, controlled, and approved. Are the machining data correct? Has the tool been correctly presetted? Has the tool been calibrated in the correct way? Did you think about how you're going to remove the ships from the hole? All of those things needs to be taken care of before you can say, now we are ready, we start the operation. Here, what I showed you in a couple of slides, as I say, if we talk about a real boring seminar, we spend 3-4 hours on this, understanding boring as a process, what's going on, what's the difference between, I don't know, staggered setting and symmetrical setting in rough boring. Do I use a solid carbide boring bar or do I use an insert? All that type of things. Here it's very, very, time depending, very short. But boring is complex. It's precision operation. And making sure that all the choices you need to make, the tool type, the setting, the machining data, the cooling, and so on, make sure everything is correct. I add this chapter because, it's part of the game, troubleshooting, very short. Here, I would say this is not exceptional. Here you see all the classic troubles you can have with a tool. Wear patterns, ship evacuation problems, the surface which is no good, all that type of thing. And what is important to know is that in boring, a lot of issues you can have with the quality of the finished hole depends directly from not only how you use the tool, but how you did your tool selection and how you did your setting of the tool. How did you prepare the tool? How did you manipulate the tool so it's in the best possible situation to do the operation? If you talk about boring as an operation, and if you talk about troubleshooting, what you see is that a lot of things, that's at least my experience, it's very seldom that you are going to have problems with a broken tool or stuff like that, at least if you do your preparation work well. But in boring, I shouldn't say 80% of the cases where people say we have an issue refer to quality of the hole. Quality of the hole can be dimensional, out of tolerance, can be surface roughness, can be the shape, can be the form, can be the position. And here again, that's why I give you the table. It's a bit of a recipe method. If you have this, and if it's considered to be an issue, well, here you find an overview of what is the possible cause of the problem. I think it's always interesting to know that. And how or what can you do to correct it? Now I would like to give the word to my to Fabio, my colleague, to talk about boring with boring bridges, boring as an operation in big holes, because that's rather, I would say, one of the key benefits of boring as an operation. The diameter of the hole in size upwards, there are no limits by means of speaking. If you say I have a hole diameter 2 meters and I need to finish it, there are boring tools for that. However, if I so far said boring is an operation that demands seniority from the operator, the engineer, in case of working with boring bridges, that's one level higher even. But I give the word here to Fabio to talk about that a bit.
Sorry, here we are. Hello, everyone. Today I'm going to show you like a customer success story with our client, and and after that, just a quick overview of our range of large boring bridge solutions. The client was Mino SPA, is a company in near to Alessandria in Piemonte region, and their main business is to produce rolling mills and strip process equipment. And because they produce themselves the machine, they have to machine the part inside the company. Just before to start, I love to share you just a curiosity, a fun fact that I've learned visiting them. And then it's about the aluminum foil that I didn't know. So aluminum foil is produced by rolling, and then because it's so thin and so delicate to produce, during the last process, the last part of the process, there are two layers of foil that are rolled together, that have been rolling together, and that's why we've got one shiny side and one matte side, because the layer that are inside, in between, in contact with the other aluminum foil, it remains matte, and the outside layer that is in contact with the rolling is become shiny because of the pressure on the material. And that's just to know a curiosity about that. What was the case? In the client contact us because they had this new machine, this big portal machine, and then they have to machine this big bearing housing, and then they need to bore the inside of the hole. And because of that, they need a large boring bridge. So the first challenge that we had when we visit the company and take a look of the application was that because of the structure of the machine, the head is moving upside down, and because of the side of the hole to be machined, the head needs to go through the hole to machine the full length of the hole, because it was so deep. And then was the first concern was about to verify and be sure that there were no collision with all the accessories around the head to the workpiece. And that was fine, because also the diameter was big enough to make it work. So we got a very good portfolio, I would say, of bridge bars. And at the start, just looking at the draw and the workpiece, we started with the first technical evaluation, and we create the first assembled base of the tool, and that was the one that we created. On our portfolio of tools, the bigger size bridge are called jumbo. It's just a commercial name, but just to distinguish them from the normal size, they are around 600-700 millimeters. When we go above this diameter, the bigger size are called jumbo. So that was the theoretical assembled tool, but because of some issue about the weight of the tool that was really heavy, we decided to switch to the smaller size that on the paper wasn't able to reach the length of the diameter. So we had to modify and to adapt an insert holder, and that's give you the idea that what's on paper, what's on the catalog is not always doesn't always go perfectly what the practice. In the practical case, you've got always to adapt or to see what's the ready needs are. And so in that case, we adapt and modify an insert holder that was slightly longer, and then we can reach the correct diameter, reducing the weight of the tool about of the 20-30%, and that was better for the machining process. Here we got some picture of the tool and of the machining process. You can see that from there, the first picture is with the tool mounted on the machine head and ready to work. Here you can see the first test we did, and then the first bit is already machined and shiny, and the bottom of the hole still raw. And that's from the bottom. You can see that the dimension. I don't know if the picture can give you the idea of the size of the workpiece, but yeah, it was really impressive to see and to see the machining process. What happened then? We machined the bearing housing, and the client was happy of the solution, because we realized the piece in the reasonable time with the really very good tolerance and very good very precise machining process, really stable. And then that's why they decided to implement the Jumbo tool in their production line. And that's also they appreciate the ease of use, and how the tool was easy to assemble, easy to adapt, and easy to work with. So now we are gonna see an overview of our catalog portfolio of tools. The large diameter boring solution. We call large because, as Patrick said before, we are talking about bigger size, bigger than average, bigger than standard, I would say, with the bridges. So with bridges, we start with what we call a single bridge, like that you can see here in the picture. We got the bridge, and then we got the heads that can be mounted on the bridge, and then every bridge has a two side where we can mount the head, and then we can have a little bit of movement where the head can move for change diameters, and after that we have to switch to another dimension to a larger bridge. When we go into very large diameters, I mean bigger than 600-700 millimeters in our range, we have to switch to the jumbo size, we call jumbo size. When we got another different bridge made of aluminum, and then we mount, is a modular system when we can mount the normal bridges on the bigger bridges, on the big bridge. Then we can reach the diameter that we need. We also can put all the same cartridge and adapter and head that we can mount on the normal bridge for different kind of machine needs, for internal, external, for pulling, for different kind of necessity, and so on. We can design some special tools for different application and for different diameters. Of course, all of the tools, all of the bars has got internal coolant, and the coolant can reach the cutting edge of each insert. The main thing of the application is the stability, because it's a delicate operation, it's a finishing operation, and it's really, the tool is stable, and then the insert will work really, really well and with constant with a good finishing surface, a finishing result. So the connection is also really important. We got all the different type of connection for different machines, and also for some kind of machine, it is possible to attach the bar straight to the head, and that's even more stable and more effective. That's what we did in the previous application I show you. The boring bridge, as the small boring heads, can be used with rough boring blocks. So we can put two boring blocks with two insert for the roughing of the hole if we need to, and with all the different insert, all the different cartridge and insert holder. And as well, as we saw before, we can put the finishing block. And in that case, because of the size is not something we can see in the normal boring heads, we got another block. This is just a counterweight block, because of the stability, and the block is not lightweight. It weighs around a kilogram or maybe more, and then we need to balance the weight to keep the stability and the effect in the process effective and controlled. So I'd like to give a special thank you to Gianluca for the collaboration on this project that helped me a lot with this boring bridge. Thank you. Now I think we can go back with Patrick.
Thank you, Fabio, for the presentation. Boring with boring bridges, as I already said, boring as an operation compared to traditional turning milling, in my eyes at least, is a bit more demanding from the operator, the engineer, about handling the tool and knowing what's going on and correcting. Boring with big boring bars, with boring bridges, with jumbo bars, as Fabio called it. I think it's even more important, because can you imagine a tool with that diameter and you let it rotate? Yeah, you have to be sure of yeah, what you are doing. Boring. We went very fast through this, and as I already said, don't hesitate if because I showed a couple of tables and so on. If you want to have copies of this, just let us know. We send you a copy of this. It's an abstract from a bigger course we have on boring, and yeah, perhaps here and there, yeah, because I try to flow through this thing to mention all important things, but perhaps I missed out some things. So don't hesitate to ask for more information, to put in the comments here what your questions are, what you would like to have. Boring. I take one of the sentences in the beginning back. Boring could be your last chance to have the whole right. Dimensions, shape, position, form, geometry, whatever. Don't spoil it. Because if somehow you fail to deliver and you have to scrap the workpiece, that could be not only a very expensive exercise, but also a very disappointed customer, because you have to inform him that, yeah, there are some issues with the delays. And remember the workpieces you produce. Remember what Fabio showed us. Those workpieces are, yeah, by their size, by their dimensions, by their complexity, not cheap things. Scrapping it is a serious thing. And some people even say, yeah, but it's not so bad, we can rework it. Yeah, but even the rework will take time, will cost you money. You will have to call the customer and saying there will be a delay in delivery. So it's your last chance to make things right. Hopefully the first time. If you miss it, yeah, you have some issues. So give it the attention it deserves. If you want to have more information, you can call me or contact me, but of course also Fabio, Alesia, whatever we can help you with. Just let us know, and we see what we can do. Remember that you have the possibility, perhaps some of you already took the opportunity, and I would say take the opportunity here. If you have more concrete questions, yeah, make an appointment, talk with our boring people, experts, and they will help you with whatever questions you have for your applications. Because remember, what Fabio showed us was one application, very specific. And I'm pretty sure your applications also are very specific. And general answers is not always what you need to handle a specific operation or situation or workpiece. Take the opportunity, make an appointment. We are coming close to the end of this session, but let's see first if we have questions here. Yeah, I see there are some questions, some General questions, some specific questions. One question is, can boring correct the position and straightness of a hole? Yeah, the answer is simple, yes. Boring as an operation, due to the mechanics of the operation, if the pre-hole is a little bit out of position, boring can correct that. Most probably you will have to do it in kind of two steps. First, a rough boring operation and then a finishing operation. But boring can correct within limits. If your hole is 5 centimeters out of position, yeah, obviously boring will not correct that. Within limits, boring can correct the position and also the straightness. Boring, finish boring being a one cutting edge operation, how should I say this that you understand what I mean, will not follow the existing hole. If your hole is like this, a drill, for instance, if you use a drill to widen the hole, well, a drill will follow this, will not correct this. A boring operation will. What is like this, after boring will be like this, again within limits. If the straightness of the hole is 5 millimeters wrong, yeah, boring can do a lot, but not everything. But the question, can it correct position and straightness? The answer is yes. Wait, this question. Any variant of a boring bar in which size can be adjusted by the value in the CNC macro? I mean an electronic adjustment type of the boring bar. I think this is a question that demands knowledge of the product range. Can I ask you, Fabio, to handle this one?
Yeah, I think that the product we was talking about is not adjustable with the CNC macro, but is only adjustable from the tool, straight on the tool, and is not something that can be electronic adjusted by the macro. We can adapt the parameter for the machining, for the speed and so on, but we cannot adapt the size. The size cannot be adjusted with CNC macro or electronic adjustments. I think that's if I understand correctly the question, that's the answer.
Good, thank you, Fabio. If the person who asked this question is not having the answer, or if you meant the question differently, please put in the comment again, and we take it up later. We have some time left. Boring tools are very expensive. They are expensive, but I don't know. They are expensive. And if you work in small batches, is it a responsible thing to do, to buy boring tools to produce a limited number of parts? I give you an answer in two parts. One part is, there are situations where boring is the only option you have to reach the needed quality. Then the choice is easy, I think. If you don't select boring tools to do the operation, if you don't select boring as an operation, you don't reach the quality demands which is asked by the customer, and then it's end of story. So there are situations where you have no choice. It is what it is. In another way, small batches, I would say boring is perhaps boring tools are expensive to buy, but they are rather flexible. I mean, one boring tool gives you not only one diameter you can work on, you have a certain adaptability of diameters. You have a certain range of diameters you can adjust the tool to. So, and that's a consideration to take here into account, that, yeah, if you have put it extreme if you have only one workpiece to make. And if you have the option between reaming and boring, I agree reaming is a cheaper solution from a perspective of buying the tool. But on the other hand, if you have that one reamer fits only one application. While if you would have selected a boring solution for that application, you have a tool now with a certain range you can use also in other applications. So it's kind of two considerations to take here. And then a question for Fabio also. Are there limits to cutting speeds? I suppose connected to using boring bridges.
Yes, so the cutting speed is not really an issue, because if the stability of the tool and of the part is controlled and the workpiece is stable, we can have we can use the same cutting speed of that insert can work with. Another thing that can give us a limit or to contain the cutting speed is the rotation range that can reach the bridge. Because of their weight and their dimension, they've got there are labels on the tools that say what's the rotation limit, the number of RPM that can be used with, because they're really heavy, and the weight matters in that case. So that's the only limit we can see with this kind of application.
Good, thank you. We have a couple of minutes left. There is one really very practical question, and to be honest, I'm interested also in the answer. Those big boring bridges, from a manipulation perspective, how heavy are they?
I mean, if we are talking about
tons or
like kilograms, if you're talking about kilograms, maybe then 20-30 kilograms for the jumbo bars. For the biggest size one, we are more than 10-20 kilograms starting from this range of weight, and that's why they've got some holes when you can attach some hooks for move and because they are really heavy. It is not really easy to move, and with hand you need some support or to lift them, because the weight is important, especially when you go to the bigger size, to the jumbo one, when it's a meter or above.
Good, thank you very much. So it's heavy but handable, if I can put it like that. I see we reached the end of the available time for this session. I hope you had an interesting hour. Boring as an application is a bit specific, is in a big number of cases a bit forgotten, because people think on everything as an alternative to do certain operations. But boring is sometimes, people overlook it, although I think it's one of the operations, one of the machining operations that offers us the possibility to reach highest precision, in highest quality, and in all dimensions. I would say dimensional, shape, geometry, position, surface roughness, whatever you want. If you have questions, put it in the comment. One of us will give you an answer as good as possible on your question. And then the only thing which is left for me is to thank you for spending an hour with us, to thank my colleagues for being here together with me, especially the two girls who are always in the background and always making this thing possible. Don't underestimate that. And to invite you for the next session. And the next session is one I'm really looking forward to, because I heard it so often that people say, okay, I followed all your seminars, I went to school, I did this, I did that, and then I go to the workshop, and I still have broken tools. I want to talk next time about broken tools. And when a tool breaks, what do we do? That's the main thing. What do we do if a tool breaks? One thing is, and I already want to give you that, in my eyes, breakage is not a wear pattern. A lot of people, if you ask them, teach me something about wear patterns, in such a teaching, there is flank wear and crater wear and shipping and whatever, and then there is always also breakage. Well, if I can tell you one thing already today, breakage is not a wear pattern. Breakage is a different thing. Breakage is an accident. Breakage is a mistake. Breakage is something that should not have happened. So don't call breakage a wear pattern, is different. But the subject next week is, okay, or next time we are here together, what do you do if a tool breaks? I'm looking forward to see you there and to discuss that subject with you. And in the meantime, all the best. Thanks for being here on behalf of my colleagues and myself, and see you next time. Thank you.